Let's improve our batching algorithm. Let's make it better. We made our batching algorithm yesterday. It was actually pretty good. I was actually really surprised at how easy and quick we made it work. We just did a few lines of code changes. Check this out right here. Look, it's right here. This is actually really satisfying. I was very satisfied with this. We did basically is a stochastic or random, right? Stochastic random gradient descent by using a feature where you just take all your inputs and targets and then you randomize them. So that way, when you're training them, your model would be able to make micro improvements based on the batch to adjust the weights and biases. It did a really good job, but it's not perfect. I guess I don't know how you say perfect. It's not full. It's not complete. It's missing one part. The part that's missing is you could potentially accidentally leave some of the training features and labels out of the thing. Oh, it could be empty because it randomly selects them. So it could favor accidentally a few other features than some others. And it's random, so it'll change up every single time. And it doesn't really align to the epoch, you guys. It doesn't align to the epoch. We're doing some artificial intelligence, our deep learning machine model that we did some previous streams ago, you guys. We're going to improve it. We're going to make it better. We added batching yesterday. But today, we want to make it so that way we really actually make it a true epoch. An epoch is just a fancy term for how many times you train your AI model on the complete data set. On the entire data set, how many times do you train it? Because you can train the model once on it, which is one epoch. But the model you might want to train it a few more times than just one time. and so, I mean, just as humans, right? Thank you for the likes, you guys. Just like humans, you want to sort of repeat things and learn incrementally over time, and then you sort of memorize well that way. That's how these models learn too. It's actually kind of a neat approach. I really think it's neat. But our epochs are not real epochs because we're leaving some data out. We want to change this. We want to improve the model. We can improve it. And if we have time, we want to clean up how we're leveraging the learning rate and some of these other features. Thank you for the likes. Thank you for all the likes, you guys. Okay, here's how we're going to do this. So I was thinking about this last night, but there's a problem. We've got a problem. Yeah. Oh, look at all those heart icons showing up there. Thank you. I can see this showing up there. We have a problem. We need to figure out how to organize these items in a way. Wait, hold on. Wait. Is this even correct in the first place? Is this even work in the first place? I think I see a problem. Mohammed, hey, how's it going? Hi, welcome on in. I think I see a problem here. I see a problem. What did we think? Where's the random happening? Where is the random occurring? I need to see because it does look like it is aligning perfectly. So I was gonna wonder. I was like, because the data, the results that we see in the results. Check out the results. Check it out. Let's see ML. Let's do Python. Where is it? Let's do Python ml.py. Let's let it run there. That I was mixing up the stochasticness, the randomness, but we're not, because otherwise, see here on the screen, all these little pretty green dots, all these green check marks, they wouldn't be green check marks if it wasn't working properly. Okay, so where's the random happening at though? Wait, where's the stochastic? Is it? No, it's got to be. So range for ion range int epochs times length of range. There's in right here. Here's in for range and batch. Okay, so that's the batch size, right? Oh, wait. So I do see this isn't perfect. We need to make it better. We need to make this better. What does batch mean? So a batch is just, we're going to take, so we have a large pool of training data, a very large pool of training data, but we can't pass the entire pool of the training data into our model all at once. So we have to take it in small chunks. We have to take it in small chunks, a little bit at a time. And so that's the batch size, right? And so instead of training on like 60,000 items all at once, we have to train it like at 32 items and like little chunks of 32 items. That's what batching means in this case. Check it out. All right, so what we have to do here is we need to improve this. I want to get to like 100%. So we need to do something like a shuffle. We need like a shuffle of some sort, right? But we have to do it in a way that makes sense. So for ion range, so this is the range, and then we have it batch size. So we're grabbing it in chunks. So this works perfectly fine. But is this actually already good enough? Do we need to improve this? Are we getting 100% of the data set? That's my question. So there's no stochastic training here, is there? I don't think we're stochastically training. So let's walk through it really quick. So we're looping through. Basically, we have like, say, 10,000 features, but we're looping through batch size of 100. And so that means we need to go through 100 loops, right? About 100 loops. I'm a noob. Can I ask what's the use of the improved batching algorithm? Okay. So Abdul, what we want to do is add some randomization to it. So from the batching algorithm right now, we don't it looks like it's just doing 100% of the data, but it's not randomizing it. And you want to add some stochastic to it, so that way it helps smooth out the generalization when it's learning with the input data that you're giving it. And right now it's linear. It's training linearly, and it's not training stochastically, which means just randomly. You got to want to trick it. So that's what we want to do. Blum, did you get the epochs and learning rate fixed up? I did. So that's actually something that we could do really quick. We could clean that up. I want to make this better. Okay. So how do we make that better? So we could have it, we could put it on initialization of the model, but we also, I think having it here on the train is fine. And so we set the learning rate here, but here's the problem. It has to get passed like this, and I don't like that. I do not like it. I'm not a fan of this. I would like it to be better. So we have to do it like that. So the optimization has to be here. Can we update it so that way so I just don't want to have to keep passing it like this a whole bunch. Let's see if we can make some adjustments. So I want it to be this. I want to use self.learn. I think that's better. Thank you for the likes, you guys. Here, let's see if it still runs. I want to make sure it still runs. We're in a good spot. Yep, looks good. All right, cool. We're in a good spot. All right. Self.learn. I don't want to pass it in here. I don't want to have to pass it in here. And I don't want to have to pass it in here. Right? So that's what I want to do. That's the adjustment I want to make. But here's the challenge, though. Can we update? We need to set the learning rate on the layer. We are building our own machine learning framework from scratch, which we succeeded right here on the screen. Check it out. We're successful. You can see it. It's very successful. But we're making improvements now. So I need to add the self-learning rate. That's what we're going to do. Why don't you just use Keras? Oh, Stru. Yes, Keras is the way you want to do it. So because we're implementing the algorithm by hand ourselves for learning purposes, in order to learn how to use AI, I think just implementing the core algorithms yourself is really beneficial. We are teaching how to build your own deep learning framework from scratch. Deep learning from scratch here. This is actually part 6, batching improvements, but we might not have time. Batching improvements is what we're doing today. That's what you're doing. I just came on. Okay, let's see if I can. It's trying to catch up with the jets. So we are improving our batching for our own deep learning neural network that we wrote from scratch, live on stream. We did it live on stream without the help of AIs. We did it all by hand, only using NumPy. And you can see here that we were successful at doing it. And this is the main code. This is the main code of it right here. So that's what we're doing. That's the plan. The more data you give it, it gets smarter. That's what it is. You got some efficiency there, some smart efficiency. Okay, let's see if we can do this really quick. And then I do have to get going because I know I have this other meeting that's going to start here pretty soon that I got to jump into. But we have to do this one thing. So this layer needs a training. We need to be able to get this self.learn in here. Just making some adjustments to our deep learning model that we wrote from scratch. Drawing Brothers. Now we can create our own artificial neural network from scratch without any framework, no limitations. Like, I really want to fix this part right here, this self.learn. I think we can do it by maybe, wait, model layers. Okay, so we should do this. Hold on. How do we do this? For layer in layers. Learn is going to be, learn. Let me just say, learn, something like this. I think maybe, is this okay? Can we do it like this? So then when we're initializing the model, how did you adjust your parameters for your back propagation? Here, I'll show you. It's right here. It's really easy. Right here. The optimization. Here you go. This is it right here. 100% on the screen. Look, it's only 2 lines of code. Isn't that amazing? Isn't it amazing? I think it's amazing. Can you include artificial intelligence for environment conversations? Yes, you can. You totally can. In fact, you kind of need to, Ashford. You really need to, because what we need to do is take all this environmental data and leverage artificial networks to train and predict future conditions of the planet. Future conditions of the planet, we're making it warmer, global temperature rises, right? So climate change, we can need AI to make our lives better. That's what you got. That's what we need to do. One last thing to do, end-to-end machine learning projects from scratch for your channel. Stu, that's actually what we did. That's what we did. This is an end-to-end from scratch. So we actually did this. So we've did this in previous streams, which you can still access. The video on demand is still available.